Okay, this lecture is over Chapter 6 of your textbook, which is titled Location Awareness. In this chapter, we'll talk about some things related to locations and networks or computers. First, we'll talk about exactly what is location awareness. We'll talk about different ways to get location information. We will talk about location-based services and how they work. And we'll talk about determining position from Wi-Fi information. So first, what is location awareness? And what I came up with was this was acquiring information on the physical location of a computer, user, or other devices. One thing to note when you're investigating an incident is that the computer that is compromised or that is being used to perform an attack may have one location, and the user that is performing that attack may be located somewhere else. So those locations could be different. There are different ways and topics related to obtaining location information. The first is not necessarily the greatest, is time zones. So if you have messages that are originating from the Pacific time zone, you might assume they're on the western part of North America, for example. But time zones can be changed either to hide location, or maybe they're just set wrong and whoever administers the computer hasn't bothered to set it or didn't know how to set it. Another thing, and again it works in some cases and not others, is the who is command or who is websites. Basically, you have a domain name or an IP address, and you basically say, who is this? And it will come back and tell who it's registered to. So if it's a smaller company, it's going to have an address, let's say, in a particular city, and most likely anything with that organization's IP address or domain name is probably going to be in the same city. Now, this won't work for somebody like, let's say, Amazon, who, that may be registered in Washington State. I have no idea where it is, but let's say that's where their corporate headquarters are. However, all over North America, there are going to be facilities that use IP addresses and or domain names that belong to Amazon. So sometimes that's helpful, sometimes it is not. Another command we will look at, and your textbook talks about, is the traceroute command. And we'll talk about that in a little more detail, but that actually shows you the route that packets are going to take to get from one machine to another. Another topic we'll talk about is geolocation. What does that mean, and what are some examples? And we'll talk about location-based services such as Apple's Find My, and we'll talk about those, and then we'll talk about Wi-Fi positioning. So those are kind of the 6 major topics that we will be talking about in this chapter. So we'll dive into the first one, which is time zones. And what I have here is a little graphic that relates to time zones and how they might, quote, betray you. So, wrong time zone, if you take that as fact in that location, that may cause you to come to wrong conclusions. Most sites use either UTC or the local time zone. When you're doing an investigation, you need to normalize your times to either UTC or the local time zone, whatever is easiest and whatever makes the most sense to you. Also, daylight savings time. If that's not set correctly, you could be off by an hour. Also, what happens when you go to 2 a.m. and then you fall back, for example, and all of a sudden after 2 a.m. comes 1 a.m. again, and then you go through 2 a.m., and on from there. So daylight savings time and time changes can cause problems. In the case of cloud logs, maybe you're using the time zone of the data center where your servers exist instead of local time zones. Attackers may try to mess with the time zone and clock so that you have trouble tracking down what's going on. And then you need to document what you're doing. So down at the bottom it says normalize first, synchronize your evidence, your artifacts, and then document that so that you try to prevent problems that can be created or confusion that can be created from time zone information. So I said this a moment ago, some log files do UTC, which used to be called GMT, Greenwich Mean Time, is now called UTC, or the local time zone. Those are the two most common things for log files to use. The user may or may not be in the same time zone as the machine they're logged into. So we could have somebody from Russia, for example, logging into a machine in Lexington, and their time zones are going to be very different. Their location is going to be very different. The other thing too is there are different ways or different places you can set the time zone on a machine. For example, your operating system has a mechanism for setting and processing time zone information and what format you would like your dates and times to appear in. Let's say that we use Eastern time zone for the operating system because we're in Kentucky, Lexington. Your database server may be using UTC, so that can create confusion related to the time zones. So you just need to be aware of that and account for that. The next is the whois command, and basically there is a whois database that stores information about domain names and IP registrations. And within this database there are going to be things such as the name of the person who registered the information, the organization that this information is related to, a physical mailing address, phone number for the registrant, the email address. Actually, there are going to be several email addresses. There's going to be the main contact email address. There's going to be the billing address. There's going to be the administrative address. And there are other information that we'll see over the course of the textbook or homework assignments that are stored in the whois database. The next command the textbook talks about is traceroute, and as I said before, it traces the route a packet takes from the machine that the command is issued on to the destination machine. This comes from the Unix command traceroute. In the case of Windows, because in DOS there used to be an 8-character limit on file names and therefore command names. So if you're in the Windows CLI, the command is going to be traceRT. But they both do the same thing. So here's an example from my computer. So I'm on my computer, logged into my account, and I do a trace route to Google. So it'll start going, and line 1, the 192.168.0.1, that's my default gateway which is my Spectrum router. From there, it goes to Charter in Lexington, bounces around within Charter for a long time. Then at the bottoms, hop 8 and hop 9, we have some IP addresses, but they don't resolve to names. And this continues on for a couple of more slides. So on hop 10, 11, 12, 13, 14, we have just IP addresses. The other thing that's interesting, and this is typically, I would say, not the case, is for each of these hops, we have 3 different IP addresses. And what that means is it tries to send 3 packets to get timing information, and each of those packets has taken a different route. So that can be a little puzzling at first, but that's the reason for that. And then hop 15, 16, 17, those don't have names either. They have either 3 or, in the case of hop 17, 2 different IP addresses. And then finally, we do have an IP address, but it resolves to a name, the 1E100.net. And for each of those hops, it gives you timing information. Now, if this hasn't been explained to you before, traceroute's kind of interesting. I'm assuming that everybody is familiar with the ping command, where you send an ICMP packet to a host and it gives an ICMP reply, and from that you know that the path to that device is up and working because you got a packet to go to the device and a packet to come back, and it also measures the speed of that connection. Now, at some point somebody said, you know, we can kind of mess around with the time to live on the packets and get better information. So a normal ping packet has a time to live of, let's say, 128. And every time it goes through a different device, that is decremented by 1. And if that count ever makes it to 0, it will return the packet. So what happens in a normal situation is normally that time to live doesn't go to 0 unless you get in some kind of loop where the packet's bouncing back and forth between 2 devices. Well, somebody said, what if we set the time to live to 1 and send it to, in my example, google.com. So it'll go from my machine to the router. The router will decrement the time to live to 0. That packet will be returned. So because that packet will have a source IP address when it returns it, I can figure out the IP address of the first hop, and I can get timing information too. So now I set the time to live to 2 and I send it to Google. When it goes through my router, the time to live is decremented down to 1, and when it goes to the next hop, which in this case would be my ISP, that time to live is decremented to 0 and that packet is returned. So that process continues until it actually makes it to the destination machine. So just kind of a trick that somebody thought of using the time to live in the ICMP protocol. The next thing is geolocation. And geolocation is trying to determine the location, that is the geographic location or the physical location of a device, a user, or a network connection. And there are a number of sites which help with this. There's iplocation.net, iptrackeronline.com, infosniper.net, db-ip.com. I'm sure I will have you look at and possibly use one or more of these sites in an upcoming homework. It can be very interesting, and also let you determine how accurate or inaccurate you consider some of these sites. Location-based services is having an application, a device, a phone, etc., to try to determine where it is. So long ago, when Apple came out with the iPhone, they had something called Find My Phone. And then they added laptops to it, they added tablets to it, they added Apple Watches to it. They came out with Apple AirTags that all use this service, so they changed the name to just Find My. So basically, Find My Device or AirTag or whatever it might be. Now, Google came out with the same thing called Google Find My Devices that is within something that is called Find Hub. Some devices have GPSs built into them that can be used. One of the first methods often used in criminal investigations was cell tower triangulation. So if you have 3 or more cell towers and you measure the strength of the signal of each of those towers, you can kind of figure out where you are within that triangle of 3 cell towers, for example. The other thing you can do, and Apple did this a long time ago, is you can look at nearby Wi-Fi access points and try to determine a person's location based on Wi-Fi signal. So we'll talk a little bit more about that. So you look at what Wi-Fi access points you can see. You don't have to be authenticated on them, you just have to see them. And what is their signal strength? And from that, you try to determine. Google has something called Google Location Services. Apple has their Wi-Fi location database. There is a website called Skyhook that does the same thing. And then there's either Wiggle or Wiggle, I'm not sure how they prefer that be pronounced, that also does Wi-Fi positioning. And I will probably have you look at one or more of these in a future homework assignment. So that is the end of my lecture for Chapter 6 of your textbook on location determination.